Hello and welcome with the OPC Foundation. It's a pleasure for me to announce our next guest. It's a personal pleasure for me because I know Peter Seeberg for years. But for a starter, Peter, please introduce yourself. What is your job? And how do you have come to work with artificial intelligence? This is our topic today.
Oh, certainly, Stefan. Thank you very much. Yeah, my name is Peter Seeberg. I was born and I studied computer aided design in Delft. That's in the Netherlands. I've worked about 25 years in IT, most of the time with Intel, but also for a number of software companies. And about 10 years in industrial space, mainly discrete, but also process automation, which is the time that I've come across OPC UA technology. And as you just mentioned, you and I, together with a couple of other folks, we've been traveling around the world and making OPC UA known to the world. So I've dealt with introducing AI, artificial intelligence, into industrial space for the last 10 years. And I've been an AI consultant for 3 years now. I live in the Munich area. I write books on artificial intelligence, and I co-produce a number of podcasts on the topic of AI and also OPC UA.
Yeah, definitely good times we share together. So since when exactly does artificial intelligence exist? Was there a specific starting day? And by the way, is there a specific definition and rule for what we can call artificial intelligence? And isn't it just a normal algorithm which is helping us to do our job?
Yeah, the term AI exists since a long time. Actually, the 1950s, it was first used by a guy called John McCarthy in an invitation for which was a 2-month study of artificial intelligence, and that was carried out during the summer of 1956 at Dartmouth College in Hanover. That's not the Hanover we know in Germany, the famous Hanover Fair, but that's the Hanover in New Hampshire in the United States. And he talks about, and I quote, every aspect of learning or any other feature of intelligence that can in principle be so precisely described that a machine can be made to simulate it. So that is, let's say, the rules-based approach to AI. And 3 years later, that was 1959, there was another guy called Arthur Samuel, and he defined the term machine learning. And that is today's most important way of doing artificial intelligence. And I quote again as the field of study that gives computers the ability to learn without being explicitly programmed. And let's call that as the probability-based approach to AI. And then there's a third important person to mention, that's Alan Turing. Many of you have heard about him. And he already in the 1950s, he asked, can machines think? And what he does is he develops a game which since then has been known as the Turing test. And the Turing test is there to help decide if algorithms show intelligence. To conclude, today we do not have a single definition of what is AI, but that's not really different from having not a single definition for what is intelligence. One important differentiation that we can make is between weak AI and strong AI. The latter is representing algorithms at some point in time in the future, reaching the same level of intelligence as humans. And that's a concept which is targeted by, I would say, a small group of worldwide researchers. And on the other hand, we have weak AI. It's representing algorithms that can do all kinds of things for us humans. Good, but also evil. And at the same time, this is the basis for my personal definition that has worked well for the last couple of years, being algorithms as a tool in the hands of humans that recognize patterns in data that are too complex for humans to recognize. And they support us in our daily lives, hopefully doing good things, but sometimes also bad things.
So, indeed, very interesting, Peter. So, is artificial intelligence then more a threat or is it an opportunity? This might be very emotional for a lot of listeners.
Good question. I guess that most of us have heard about the results from various researchers in the field in the last couple of years, actually, saying that whatever 50% maybe of jobs will be taken over by AI, and on the other hand, creating more or less new jobs that did not exist in the past. As a global community, we could decide to deal with AI if that was what we wanted, let's say similar to dealing with climate change. Now, as far as AI is concerned, the opportunities are so huge that many countries, not only the United States, China, also Europe, all of them would like to play a major role, a global role in being or maybe becoming an AI powerhouse. Each of them more or less regulating AI for the good of business, the party, or the people, depending on what part of the world we're in. So for what we are together here for today at Achema, AI is to be considered as a huge potential, I would say, for bringing the process industry to a new level of products and execution. So what I would like to suggest to any listener is that your job, whatever your role is today, will change a little or a lot. And my suggestion is don't wait for AI to take away or change your job. Instead, sit together with your manager and agree on what it is that your parts of your job are going to be taken over by AI in the near future. Maybe just slowly phase out of them, let them go, and agree on which are going to be the new activities that you will be in charge of instead. And then also agree on the training, on the continuous training that you shall receive for the upcoming years to get into your new job and manage your new activities in this world of AI.
I'm hearing you and your call for us human beings as we should see it as an opportunity here. Okay, good. So please, can you give us some more examples of real use cases of artificial intelligence in the process industry?
Yes, without going into much detail, because any of the listeners can do that by me saying that I recognize two major, I would say, categories of AI in process industry, which are optimization on one hand and new product development on the other hand. So let's start with optimization. Depending, or let's say independent of the listeners having a problem, maybe not reaching your target quality, downtime, or throughput numbers, whenever we humans, we cannot find further improvement of such efficiency indicators, machine learning algorithms may find patterns in your data which are too complex for us to recognize, and they may result in less downtime, higher quality, or more finished products per time unit. Specifically, so-called process mining technologies, they can help you trace back original situations in complex processes that cause problems further down the line. And after finding such problems, you will then decide, if it's only a small thing, you may want to make just one or the other engineering change. So, although of course process industry is kind of complex, but maybe then a week or a month later, everything will be working fine if it's a small thing. But I would believe, and my experience says that more typically, if the issue at hand is like a large thing, you may rather want to place a digital model in or close to your plant. That means that algorithms will be looking for similar situations to occur in the future. And they will handle, at least with a yellow, orange, or red light on the control panel, or maybe automatically change, deviate from the standard process in order to, for example, prevent the plant to come to a standstill. So future plans, they will contain any engineering changes, any updates, and specific machine learning approaches, for example, so-called reinforcement learning, they will help you come up with structurally new process approaches, and they will also help you design new products. So humans can pick and choose one by one a potential solution, maybe out of 1 million or 1 billion space of possible solutions. And then we can have a team spend a week or a month or longer before reaching to a positive, but also normally a negative conclusion. Now, on the other hand, reinforcement learning can have agents test in that same space of millions or billions of potential solutions, and they can do that on the basis of predefined criteria within days.
Okay, thanks. So what I learned is that first of all, the process is to collect a huge number of data, to then start the process to analyze these data. Obviously, I have to ask, what is then the role of OPC-UA to collect these data? Because first you need connectivity to the plant, to the assets, to collect all these information. So what role is OPC-UA in combination with artificial intelligence here?
Yeah, thanks for asking. And I really can only say that for me, OPC-UA and AI are like a winning team. And I'm going to explain you why I believe that. The typical way to go about introducing AI independent into what area you do so. Let's say, so talking about machine learning into your plant, you would start doing an assessment. Maybe you do a workshop. You do some brainstorming, you're going to see what use cases do we have at hand, do we have data, what's the quality of the data, and then you're going to have to define some goals, what it is that you want to reach with introducing AI. And at the end of maybe, like a a day workshop, at least you should agree within a team of persons, the top 1, 2, 3 test use cases. And my guidance would be to start small, to go for a step-by-step execution. Don't try to solve the world's problems just from the beginning. Do it step by step. So then, if you then say, okay, now we have a 1, 2, 3 priority use cases, do a proof of concept on number 1. So maybe a POC for 3 months or 6 months, depending on the scope. Now, let's say you go for the 3 months POC. What you need to know is that typically, and you can ask really any data scientist for their experience, the rule is that about 80% of the work done by the data scientist is about cleaning, also called cleansing the data. So first you're going to have to find data, and typically, as most of you listeners know, you will find the data in many different departments, silos, responsibilities, not that easy. Then you need to understand the data. What are the variables? Because of the lacking information, you need to go and find somewhere a report. You need to fill in the missing data points, etc., etc. So until you have a clean data set, that you then have a high expectation that algorithms are going to find patterns in them and help you solve your problem and reach your goal, within the 3 months, the 12 weeks that you have, you will have already spent 9 weeks finding and cleaning the data. Now, with OPC-UA in your plant, you can almost immediately start applying AI algorithms on the defined variables in the information model. So, day one that you start doing your job, first thing you will do is you're going to look at the OPC-UA information model, which, because it has been an integrated structural element in the running plant, the information which you will find there, is up to date. And you have all the information available at your hands, the data points, the variables, the relationships, and you can start right away maybe choosing what part of the information, so what data, what section of the model you're going to be using for your POC, and within the hour, you can feed your data into the machine learning algorithms. So as a close, here you are, 3 months time available on day one, where you would normally be after 9 weeks, or maybe even further, because even after the 9 weeks, you could find out you don't have any relevant data. Not so with OPC UA. So I can really only say, as far as I'm concerned, OPC UA is the perfect match for making AI come true in the discrete, or specifically in this case in the process industry.
Okay, Peter, that's a very promising win-win situation for OPC UA and artificial intelligence. Interesting that there are so many flavors of OPC UA and the benefits. So some people think, okay, I can protect my data. I'm able to exactly configure who is able to read and write my data, and I want to own them. Some of them I want to share, and so the security aspect is given for them as one of the biggest benefits. Here we learn for artificial intelligence, it is to have data in a specific context, that we have a meaning of the data, so we have better information, and I learned we can save a lot of time here. That's definitely great news and good benefit. So, Peter, it was a pleasure to have you as my special guest here today. Again, I recommend to our listeners the books from Peter. He's a dedicated expert on multiple presentations here in Germany. Peter, thank you so much for your time. And for the listeners here, please stay tuned and follow other sessions. Thank you. Bye-bye.
Thank you, Stefan. It was great to be part of the show.